Good afternoon. Today we'll present our teleradiology outsourcing proposal. This project explores how teleradiology can be implemented efficiently and secured through third-party services, especially to improve healthcare access. Teleradiology allows radiologists to interpret medical images remotely, which is especially useful in areas where there's a shortage of specialists. It improves access to timely diagnosis, reduces patient wait times, and ensures continuity of care, even during emergencies or high demand situations. Our proposal outlines the implementation of a comprehensive teleradiology system using an outsourced device. The system relies on scalable cloud infrastructure and follows international standards for data security and interoperability. Our main goal is to ensure reliable diagnosis while protecting patient data and optimizing technological resources. To ensure an efficient and secure workflow, we propose using an architecture based on PACS, which is Picture Archiving and Communication System, and RIS, Radiology Information System. These systems will be integrated using international standards like DCOM and HL7, which guarantee interoperability between different clinical platforms. We recommend an hybrid cloud solution with geographic replication RAID 6 storage to provide high availability and scalability. The system must guarantee 99.95% uptime, a recovery time objective of less than an hour, and a recovery point objective of less than 15 minutes. PACS will manage the secure storage and distribution of digital medical image, while RIS will handle administrative tasks like scheduling, reporting, and patient history. This system compiles with NOM 024 in Mexico and supports data integration with electronic health records, ensuring a robust and legally compliant solution for medical imaging.
To meet diagnostic quality criteria, the display devices used by radiologists must comply with standards from institutions like the FDA and the ACR AAPM SIIM. For X-rays, we recommend monitors with a minimum resolution of 3 megapixels, a contrast ratio of at least 1000 to 1, and brightness above 500 candelas per square meter. For CT scans and MRIs, a resolution of 3 to 4 megapixels and similar contrast are recommended. For mammography, displays must reach 5 megapixels with 600 candelas per square meter brightness. All monitors should support the DCOM Part 14 grayscale standard display function and be regularly calibrated using tools such as Barco QA Web or RADICS. Calibration frequency should be adjusted depending on the modality. Monthly for mammography, quarterly for X-rays, and semi-annually for CT or MRI. A high-functionality image viewer is essential in teleradiology. The platform must support advanced clinical tools such as multiplanar reconstruction, zoom and panning, linear and angular measurements, region of interest detection and quantification, and structured report generation. In terms of standards, the application must comply with DCOM Part 10 and DCOM web protocols like STOW-RS, QIDO-RS, and WADO-RS. It must also support user profiles, role-based access, and digital audit logs to ensure accountability and traceability. Usability must follow the principles of ISO 9241 210, which addresses user centered design. And the interface should be intuitive, requiring no more than 3 training sessions to master. It should be compatible with common operating systems like Windows and Mac OS and accessible via web browsers using HTML5 and WebGL for full remote functionality.
For image transmission, we recommend symmetrical internet connectivity of at least 100 megabits per second, supported by redundant links and electrical backup system. A virtual private networking will ensure secure communication between institutions, while servers must be hosted in ISO/IEC 27017 and 27018 certificate data centers warranting cloud security and personal data protection. Furthermore, we recommend using DICOM Web over HTTPS and TLS for image distribution. Also, the use of HL7 version 2x over VPN for sending and receiving messages, and HL7 FEAR with Autumn 2 or JWT for RESTful API-based integration. The infrastructure should be high availability with load balancing and distributed architecture to keep the system online even if a part of the network fails.
Protecting patient data is a top priority in our proposal, which is why we propose a TLC 1.3 encryption for data in transit, a AES 256 encryption for data at rest, and a role-based access control and a multi-factor authentication. Digitally signed audit logs to ensure traceability, and an encrypted backups stored in geographically separate locations. Best practices also include the principle of least privilege, granting access only to authorized personnel, and reviewing access logs every 72 hours. Strong passwords, policies, and regular cybersecurity training should be also enforced. All of these align with the Mexican General Law on Data Protection, the HIPAA, and the international standards such as the ISO and the IEC 27001 and the 2771. In conclusion, our proposal combines cutting edge technology with rigorous compliance to deliver a high quality, ethical, and secure teleradiology system. We are confident this model will improve diagnostic care and demonstrate our ability to responsibly use health technologies in alignment with both technical and ethical standards.